Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's hard level puzzle. And it's called Sum X Sum by Utrio. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have yin yang, where we need to shade some cells such that all shaded cells are orthogonally connected, and all unshaded cells are orthogonally connected, and no 2x2 area is fully shaded or fully unshaded. Excuse me. So this is an example of a valid yin-yang shading, because all the cells that are shaded are orthogonally connected, and all the unshaded cells are orthogonally connected, and no 2x2 area is fully shaded or fully unshaded. Now, what does it mean to be orthogonally connected as a region? It means that you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. So, for example, to get from this cell to this cell, you go along these edges here, along those edges to that cell there, all while staying within the region. This is an example of an invalid yin-yang shading because these cells can no longer connect to the other cells in the unshaded region just by going through edges while staying within the region. They either have to go through a corner or go through an edge and exit the region to get to other cells in the unshaded region. This is also an invalid shading because we have a 2x2 area here that is fully shaded, which is not allowed in yin-yang shading. So that's how yin-yang shading works. Cells separated by a white dot are both unshaded and their digits are consecutive. So this is valid here because we have both of these unshaded. And if we had, say, a 6 here, this would have to be 5 or 7 because these digits must be consecutive because there's a white dot between them. Cells separated by a black dot are both shaded, and their digits have a ratio of 2 to 1. So this is actually no longer a valid shading, but we could do something like this, and then this would be valid. And this would then be valid here because both of the black dots, the cells separated by a black dot, are shaded, and their digits have a ratio of 2 to 1. So, for example, if this were, say, a 2, this would have to be a 1 or a 4 to maintain the 1 to 2 ratio between them. And that's how the black crocky dot works. Clues outside the grid are X-sum clues for shaded cells. That is, they give the sum of the first n shaded cells in that row or column where n is the first digit in the first shaded cell that clue sees in its row or column. So this is actually not valid here because the first shaded cell seen would be here, and the most that could be is 9. And then there's not going to be 9 shaded cells in this column. And in addition, it's not going to add up to 11. But let's use something like this. Say we had a 3 here, then this would be valid if this is like 8 and 9. Because the first shaded cell seen here is a 3. That means we must sum the first 3 shaded cells in that column. And the first 3 shaded cells, 3, 8, and 9, add up to 20. So that's valid. That's an example of how these X sums work. Clues outside the grid also give the sum of all unshaded cells in that row or column. So that's not going to work here because you can't have a single digit adding up to 10. But say we had not sure how okay, say we had something like this. Then the clues outside the grid also give the sum of all unshaded cells in that row. So we could have something like, say, 1, 2, and 7, and that would be valid for row 1 because 1, 2, and 7 add up to 10, which is the value of that's a sum. That sum must be what the unshaded cells add up to. So the clues outside the grid are both x sums for the shaded cells, which is the and a total sum for all the unshaded cells. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. In row 1, we have 10. The unshaded cells must add up to 10. And the first X amount of shaded cells must add up to 10. Same with column 9. So we're going to have some swap in column 9, and we're going to have some swap in row 1. Because we have both unshaded cells and we have shaded cells in that row and column. So there has to be some swap there. What we cannot have, though, is it swap. So in a yin-yang shading, you can have either 0 changes of shade or 2 changes of shade on the edge of the grid. And the reason why we know that is, say this is one shading, and then this is a different shading. And then, first of all, you have to have an even number of changes of shading, right? If you swap one shading, you have to obviously be able to swap back eventually. But if we swap and then swap back and then swap again, you must swap back. So therefore, you have to have an even number of changes of shading on the edge of the grid. But say we had more than 2. The problem with that is, say we tried to orthogonally connect the orange region. Well, the yellow region is necessarily broken apart into 2 separate regions then. So that's not allowed. But what happens if we try to orthogonally connect the yellow region? The problem is there, the orange regions becomes 2 separate regions too, which is not allowed. It's supposed to be one contiguous region, which is orthogonally connected. That's why we know we can only have 2 changes of shading in this on the edge of the grid. So we know we cannot have a change of shading, then this change of shading, and then another change of shading here. So this must be full one region here, and then full one region here. Because you can't have multiple changes of shade. We already have a change of shading here. We have a change of shading here. That's 2 changes of shading, no matter what. And this must be at least 10 to add up to the 10 in the row for either the sum or the x sum. And this must be at least 11 here. So this has to be one shading. This must be a different shading. And this, again, we have one change of shading here. We have one change of shading here, which means this cannot have a change of shading here. So this must be all yellow, which makes this an orange here. This must be orange here, and this must be yellow here. We don't know which one is the x sum, which one's the exact, which one is the shaded cells versus the unshaded cells. This is orange. But can we ever have 10 and 10? The answer is maybe. Yeah, you could potentially have 2, 8, and 3, 1, 6 as possibilities. That could work. Otherwise, orange is the set. We have 22 here. 9 here. 15. Okay. So what are the x sums possible? To add up to 10, it could be 2, 3, or 4. To add up to 22, you can't have 2, you can't have 3, because 3 at minimum is 3, 8, 9, 3 at maximum is 3, 8, 9, which only adds up to 20. So this would have to be 4 or 5 here, because it cannot be 6, because 6 digits with a 6 either adds up to 21 at minimum or 23. It can never add up to 22. Right? Because you have 1, 2, 3, 4, 5, 6, which adds up to 21. Or you change the 5 to a 7 because you still have to retain the 6. And that's 1, 2, 3, 4, 6, 7, which adds up to 23, which is too great. So you can never add up to 22 with those digits. So, and this digit to add up to 15, it cannot be 2. It could be 3, 4, or 5. Okay. So if the yellow is the shaded region, this would have to be these would have to be the digits that would be required, which means the remaining digits in the, so this can't be 4 because it would require 1, 2, 3 here. And well, you could have 4 with 1, 2, 3 there, potentially. One of these is 2. Okay, so that if that's the case, so if yellow is a shaded region, one of these has to be 2 because there's no other place for 2 in column 1, right? Because this forms a 2, 3, 4, 5 quadruplet here, which eliminates 2, 3, 4, 5 in the rest of the column, and 2 therefore has to be one of these. So one of these would be 2 and 8. We would definitely have an 8 in one of those 2 cells if that's the case. To add to 22 again would have to be 4 or 5. We don't actually know if that's an 8. It would have to be 2 and 8 there, but the 8 could be any of the shaded regions that would be here, because these could be all unshaded. So, right. We don't know where the 8 is here. I'm gonna pause because I need to go to the bathroom. I'll be right back. Okay, I'm back. Let's continue with the solve. Hmm. If we had 4 here, that would be 4, 3, 2, 1, adding up to 10. But the problem is the minimum amount for unshaded cells would be 5 and 6, adding up to 10 in this row. So this cannot be 4 if the yellow is the shaded cells. Oh, this is 22 and 22. Because 22... Okay. Now that's interesting. So the unshaded cells in column 2 and row 5 have to add up to 22. Which means the last shaded cell must be a 1. Because 22 plus 22 is 44. And we have to have one digit that's not unshaded that has to be after. So it would be 1. And so if this were 5 going this way, or 4 or 5, this would have to be a 1, which means this could not be 2 here. So this would have to be 3, this would have to be 2. 2 and 8 add up to... but we don't know where the 8 is here. This could not be 3, it would be 4 or 5. This would have to be 6 and then shaded. The other digits, so the other digits You can't have 3 digits adding up to 10 because you would either have to be 127, 136, 145, or 235, and we already have 1 and 3 in the row. And you can't have 4 digits adding up to 10 because you have already 1, 3 accounted for. So it must be 2 digits, and this cannot be 3 and 1 or 6, so this must be 2, 8 as a pair. So you'd have to have 2, 8 there, and they would be the only unshaded, so this would have to be shaded in that case, if that were the case. We'd have to have an 8 somewhere here for the first 2 digits. How does this work? The unshaded would have to add up to 11. So this would have to be yellow going that way, because to add up to 11, you can only have 4 digits or at most. So this would have to be a 1 for the same reason as column 2. And then this can't be an exsum of just 1, so this would have to be yellow. So it's either 3 cells here adding up to 11 or 2 cells. But, okay, so another thing about yin-yang shading is if you ever have a diagonal that's the same shade, the other diagonal cannot be the same shade. So you can't have 2 oranges here, you can't have 2 yellows here. If you have 2 yellows, this 2x2 area would be all yellow. But if you have 2 oranges here, if you orthogonally connect the oranges, the problem is the yellow will break apart into 2 separate regions. Same if you can orthogonally connect the yellow regions. That would necessarily break apart the orange into 2 separate regions. So this cannot be orange, it must be yellow. Orange has to exit out, so it would have to go that way. Therefore, these 3 digits must add up to 11, but we don't have 8 available. It would have to be 8, 2, and 1, but we already have a 1 in the column. So this would be 2, this would be 8, and we'd have to have this be either 4, 5, or 3, 6. So that could work. We could have 3 digits adding up to 10 here. This is orange because of a 2x2 area that has 3 yellows in it. Orange has to orthogonally connect out. We can't have 4 digits here adding up to orange. So these orange has to go out somewhere. It can't be 2 and 2. Which means these would all have to be connected. And it would have to go out once there. This would be yellow. The rest would be yellow here. We're not sure. Orange has to go out that way. You cannot have to add up to 11 with a 1. You don't have 4 available. It has to be 3 here then. So this would be 3. This would be 2, 4, 5 adding up to 11 there. These 3 digits must add up to 11 here. This can't be 4, 5. For 3 digits adding up to 10, without a 2, it's either 1, 3, 6 or 1, 4, 5. Well, that means this would be 1. We'd have to have a 4, 5 in one of those cells. This can't be 1 for the x sum here. So this could be 2 or 3 here, adding up to 9. The remaining digits here, to add up to 20, it's either going to be 4 or 5. We don't have 3 available anymore. So far, this is working okay. Similarly here, the unshaded cells must add up to 20. So this must be 5 or less. Because if it's 5, we could have all the shaded cells add up to 20 and all the unshaded cells add up to 20. If it's 6 or more, we can't have that anymore in that column. This still looks valid. Huh. This adds up to 11. So it's 137 here. That means the remaining digits in column 9 would be 6, 8, and 9. You could have 2 and 7 there, that's fine. Or 3, 2, 4, or 3, 1, 5. Oh, these are both shaded in that instance. Oh, it has to be this way. We know both. Okay, so this has to be shaded. Okay, so everything we did is valid. Because, well, let's just continue. Everything is valid. This is how it has to be. Because we know both cells on the black near the black crop keep dot are both shaded, and this has to be shaded then. So everything I was doing is valid because they both have to be shaded. So then we know these are shaded and these must be unshaded. Okay. So again, we have a 4, 5 here connecting this unshaded cell to the rest of the unshaded cells. That's interesting. So we have one green in one of these cells here. This is both shaded, which means this must be unshaded here, must be unshaded here. Well, we don't know if this is shaded. It could be unshaded here. This is 4 or 5 there. Remaining digits of row 1 are 4, 5, 7, 9. This cannot be 4 or 5 because of the 4 or 5 pair in the box. This must be 2 and 8. Obviously, this can't be an 8. 8 has to be one of these two digits here because we only have one more unshaded cell in row 3 to add up to 10. Huh. Okay. We have a 4-5 pair here, interestingly enough. That eliminates 4, 5 in the rest of the box. So the remaining digits of column 1 are 1 through 9. Sorry, 1, 6, 7, 8, 9. Obviously, no 1 or 6 here because of 1 or 6 in the box. No 8 here because the 8 has to be one of these two digits. Because we only have one more unshaded cell left, connecting this unshaded cells to the rest of these. These are both unshaded. Okay. So that's 10, xm of 10, 2 and 8, xm of 10. This is kind of broad. This is kind of broad. We have 9 remaining in the so 1 has to be one of these two cells in column 7 because we already have ones in the boxes here. So if it's 2, 7, this has to be 1. If it's 3, so it's either 2, 7 here, or this is 3, 1, and 5, adding up to 9. So if it's 2, 7, this is 1. If it's 3, it's 1, 5 here. If you had 315 as the x sum. Oh, wait, but this doesn't have to be shaded. Shoot. We do know that the 1 has to be here, though. Never mind. Okay. Um... Um... Remaining digits of box 1, we have what? 4, 5, 7, 8, 9. Obviously no 8 there. And 4, 5 could be here as the unshaded cell to connect these. Interesting. Huh. This is a 1-to-2 ratio. So it's 1, 2, 3, 4, 6, or 8 as possibilities. We know 8 has to be one of these 3 cells here. Remaining digits of box 3, we have 3, 6, 7, 9. Hmm. Hmm. Um, so either, well, we could technically, no, we can't have 7 be there. If this is 2 digits, it's 2 and 7 adding up to 9. But we only have 3 unshaded cells at most in column 7. So one of these before this shaded cell has to be then a 7, which means this would be 3, 6, and 9 as a triplet. And that would force this to be 7 there. Or this is 3 here, which means this can't be 3, and this is 6, 7, 9 as a triplet, which means 3 would have to be there. Interesting. So those are the possibilities for 3 or 7. 1 has to be one of these digits. 2 has to be one of those digits, because there's no other place. 8 has to be one of these digits. So now we have a 1, 2, 8 triplet. Interesting. In row 2. That eliminates 1, 2, and 8 in the rest of the row. So 3 and 6 in box 2 have to be here, which eliminates 3 and 6 in the rest of the row. So this can't be 3 or 6. We now have a 7, 9 pair in column 7, which eliminates, and in box 3, which eliminates 7, 9 in the rest of the box. So no 7 here, it's 3. No 3, 7, 9 here, it's 6. That means this cannot be 2 and 7 adding up to 9. It's 3. It could be 3, 2, and 4, technically. It could be 3, 1, 5 or 3, 2, 4. We're not sure which. But the remaining unshaded cells have to add up to 9 also, without a 3 available, and without 1 out of 1 or 2. Because it's either 3, 1, 5 adding up to 9. 3 eliminates 3 in the rest of this row also. So this can't be 6. 3, 1, 5 or 3, 2, 4 adding up to 9. which means we don't have 1, 2. We didn't have it anyways available. So there have to be 2 unshaded cells somewhere here, adding up to 9. We don't have 2, 7 available. We don't have 3, 6 available. So it's either 1, 8 or 4, 5. Interesting. It cannot be 4, 5. 4 and 5. So this has to be then 1 and 8 are the unshaded cells here. Interesting. And then the shaded cells. So one of these is shaded. Okay, so then it has to be 2 and 4 left. Right? So this is going to have a 1 here, and it must be unshaded. Sorry, yes, unshaded. Because the pairs of digits adding up to 9 cannot be 3. Could be 1, 8, but it can't be 2, 7 because 7's already accounted for. Can't be 3, 6 because 3 and 6 are accounted for. And if we try to have 4, 5 there, that eliminates all possibilities for the shaded X sum to add up to 9 because it'd be 3, 1, 5 or 3, 2, 4 adding up to 9. So 1 and 8 have to be the unshaded cells. And we know it can't be 1 and 8 here, but we don't know where. So we can only have 1 cell that's unshaded here, and 1 cell that's unshaded here. So it can't be 1 and 8 here, but the thing is that you could go there, and then you block, and then go that way, and that's done. Remaining digits of this column have to be... We have 1... no, we already have the 1 there. 2, 4, 5, and 8 can be any of these digits. That was kind of cool. This portion here was very interesting. So this has to be 3, 6, 7, and 9. There's no 4, 5 here, which means all of these have to be blue. 4, 5 has to be there, which means one of these is green and one of these is blue. We're not sure which. So this is blue. This is blue. $22 here. One of these is green. Since one of these is green, the other one has to be blue. There's no 4, 5 here, so we have 1, 2, 3, 6, 7, 8, 9 here. No 1 because of 1 in the column. No 6 because of 6 in the column. This cannot be 2 or 4 here. If this is 2 or 4, it would have to be the blue cell. But then we'd have to have a 5 in between as a blue cell because the 1 and 8 are unshaded cells in this column. And therefore, this would not add up to 9 for the first 3 shaded cells. So no 2 or 4 there. It's either 5 in shaded or it's 8 in unshaded. We don't know which. Can we cut here? The answer is no. If we cut that way, these would then have to be blue. I guess it's possible, technically. You could have all green going that way, right? And then just cut out there and there. That's possible. Never mind. Okay. But yeah, this still cannot be 2 or 4. Because the first 3 shaded cells must add up to 9. And it has to be 2 and 4 with the 3. Okay. This is kind of cool, actually. Everything there. So okay. If this is blue, this is a 2x2 that's all blue, so this must be green. If this is green, this is blue, and this has to orthogonally connect, so this would be green. So either way, this is definitely green there. That's interesting. Um, hmm, hmm. We are guaranteed a 6 or a 9 has to be in one of those three cells. Huh, now this is the hard portion for me. Um, no one. So the remaining digits here are 2, 4. Oh, 5 cannot be either of these. If 5 is either of those, it would be shaded, but the problem is then the first three digits would not add up to 9 because the 1 has to be unshaded. So we have a 2, 4 here, a 5, and a 7. And those are the possibilities. Okay. Mm, uh, hmm. Hmm. This does seem kind of weird, though. So, okay, what happens if we orthogonally connect that way, and one of these has to be... Oh, that's interesting. At least one of these has to be green. And if at least one of these has to be green, the problem is we only have two more greens in column 7 to exit out. And one has to go through the 1, the one of them has to go through the 8. So since this one of these two has to be green, or one of these two has to be green, at minimum it's green here, and then this is blue and blue. But if this is green and this is blue and blue, the green has to go out here, the green has to go out here, and the green has to go out here, and that's not going to add up to something greater than 9 for the unshaded cells. So if this is, it has to connect orthogonally here to exit out. One of these three cells guaranteed has to be green. And it must exit. Actually, so you could have green, green here, or green, green here, and this is blue. Or you could have green, green here, and this is blue, and then exiting out once here. Interesting. Um, so we're guaranteed at least one of these is connecting to greens here, because one of these has to be green at least. I think 2 at least out of these 3 have to be green. We can't have just a singleton green here, because then the problem is, even though you could have blue, blue there, giving the 2x2 area that has 3 blues in it, the green has to go out here, here, and here, and that doesn't add up to 9 for the unshaded regions in column 7. It's going to be greater than 9. So, if you have green here, it has to connect that way. Or this way. Or it could connect all the way here. So at least 2 of these are green. Or you could go green here, and then this is blue, and then it connects out that way and connects out that way. Or it connects that way and that way, or any combination of digits, right? This has to be 2, 4 with 6 or 9 as possibilities. Um, if we have, okay, that's interesting. If we have 5, what does that mean? 5 here, 4 here. That means all 5 shaded cells, the first 5 shaded cells, I should say, have to be adding 1 through 5 to add up to 15. This would then have to be shaded, so it could not be a 1. So 1 would have to be here. This would be 2 or 4, because this would have to be shaded because it's 1, 2, or 4 as possibilities. 4 obviously would not be here, here, or here. This would be unshaded. So does it have to orthogonally connect? Not necessarily. This would be 2 or 4. And this would have to be shaded. And this would have to add up to 15, because we have the first 5 digits add up to 15, and then the unshaded cells added up to 15. So you can go up only twice. So this would have to then be 7 and 8, adding up to 15. That eliminates 7 and 8 in the rest of the box. So we have a 6 or 9 here. And then the other 6 or 9 is exiting out here. So then this would have to be blue. So it would be 1 through 4. So far, this is working okay. I was hoping it wouldn't, but if this is blue, this has to be green. If this is green, it would only connect out that. Oh, so this is. So we know that anyways. So let's give us that information without that. So this is green also, because it cannot. Oh. It cannot. If this is blue, this is a 2x2 area that has 3 blues, so that must be green. And if this is green, it must we know that one has to be blue, because we can't have a 2x2 area here that's all green. And so then the green would have to orthogonally connect by going out this way. So this is green no matter what. We have 4 greens here already, which means the blues cannot include the 1, can be at most 4. So this actually does have to be 4, which forces this to be 5. I don't know, I just keep going down the path that's actually the correct path. And I find the justification for that later. So this cannot be green, because we must count 4 blue cells before we reach the 1. So this is not green, that's blue. This is not blue, that's green. To orthogonally connect, this is diagonals green, so this diagonal cannot be the same color. So no blue there, it's green. Same with this. This can't be... This has to be blue for these 4 to add up to be adding up to 22 before we get to the 1. Green has to orthogonally connect out. This has to orthogonally connect out. So this is 4, 5, which makes this 2 and 8 to add up to 10. This has to be not 6, 7, 8, 9. It's 2 or 3. This is going to be a shaded cell because you have to have 1 through 5 adding up to the unshaded cells. This must be shaded also, because this has to be shaded because it's less than 5, and it cannot be the 1 because the 1 has to be unshaded. So this must be 1 here is unshaded. And these at the first 5 shaded cells add up to 15. These 2 then must be shaded to add up to 15 also, because 45 minus 15 and 15 for the unshaded cells is 15. So this must be 7 and 8. That eliminates 8 in the rest of the box, and 7 in the rest of the box. That eliminates 7, 8 in the rest of the row, and this has to be 9 and 6, adding up to 15 for the unshaded cells. So one of these is shaded, this must orthogonally connect. One of these is shaded, one of these is unshaded. We don't know which. We have a 2x2 area here that's all unshaded. Sorry, that's all shaded, so this has to be shaded here. We can't go here because it can't exit out twice. So this must orthogonally connect here. This is shaded, so it's 1, 2, or 3 here. 1 has to be one of these digits here. And we have to have 6 here also. That eliminates 1 in the rest of the box, and 6 in the rest of the box. So this can't be 6. This can't be 3. 4 eliminates 4 here. So this is 2 and 8, which is in a 1 to 2 ratio, which has to be with 4. That eliminates 4 here. No 4 here. We have a 2, 5 pair. 4 eliminates 4 here. We have a 2, 5 pair in box 9, which eliminates 2, 5 in the rest of the column and box. So no 2 there. That means this can't be 2. It's 4. 4 eliminates 4 in the rest of the column. 4 eliminates 4 in the rest of the row here. 9 eliminates 9 here. Okay. The first 4, we have 4 shaded cells here and 4 unshaded cells here. Because this must be the last digit. The shaded cells added, the 4 shaded cells add up to 22. The 4 unshaded cells must add up to 22 also. These add up to 22. 4 and 8 add up to 12. So 22 minus 12 is 10. So these two digits must add up to 10. We don't have 2, 8 available, so this must be 3 and 7 available. That eliminates 3 in the rest of the row. Remaining digits in row 7 are 1, 2, and 6. That eliminates 1, 2, and 6 in the rest of the box, so this can't be 1 or 2. It's 5. That means this can't be 2, it's 8. 5 eliminates 5 here, so that's 2 and 5. No more 8 here because of 8 in the row. No more 9 here because of 9 in the box. Remaining digits of box 8 are 3, 7, and 9. And this can't be 3 because of 3 in the row. Interesting. No 4 or 7 here. It's 5 or 9. 7 eliminates 7 in the rest of the box. So we have 2, 5, 6, 9, which should add up to 22. And it does. 2 and 9 add up to 11, so do 5 and 6, and multiply them together, you get 22. No 5 here, no 9 here, because of 5 and 9 in the box. 11 is here. So the other remaining digits, the other shaded cells in row 5 have to add up to 11 also. 22 minus 11 is 11. 5 eliminates 5 here, so this is 4, which means we have 4 shaded cells this way. And if we had green here, it has to go green there. And then we'd only have 3 shaded cells plus the 5 here to add up. So this cannot be green, which makes that blue. So this can't be blue, it's green, which must orthogonally connect out that way. So this is shaded, shaded. We have 1 shaded here and 1 unshaded here. We don't know which is which. So 4 digits add up to 20. The other 4 unshaded cells add up to 20. Where 4 cannot be here or here because of 4 is in the column. And 8 eliminates 8 in the rest of this column here. We have a 1, 2 pair now in column 4, which eliminates 1 and 2 in the rest of the column. These can't be 4 anymore because of 4 in the box. Remaining digits of row 9. We can't have 6 or 9 here, so this is 1 or 7. 1 can't be here because of 1 in the row. Okay. If this is green here, this diagonal would both be green. We'd have to have a blue there. And then this diagonal could not be the same shading, so this would be green. And then we'd have a 2 by 2 area that's all green. So this cannot be green here. It must be blue, which means this can't be blue. It's green. We cannot orthogonally connect this out by going that way, so this must be blue. So these are both blues. adding up to 11, which means the rest of these must be all green. We now have 2x2 areas that have 3 greens in them, so this must be blue, this must be blue. We cannot have 8 be here, because if we have 8 there, 8 is that would mean this doesn't add up to 9 for the unshaded cells. So it's 2 and 9 here, or 5 and 6 adding up to 11. Which means the remaining digits in this row, because of the 6-9 pair in the row, cannot be 6 or 9. So we have 2, 3, 5, or 8 here. No 8 here because of 8 in the column. No 2 here because of the 1-2 pair in the column. Interesting. Okay. This adds up to... Oh, this must be 6 here to add up to 15. Means this cannot be 6 here. To add up to 20 for these 3. Six eliminates 6 here. To add up to 20 for these 3. Sorry. For the 20 to add up for the 4 digits, these 3 must add up to 20 minus 4, which is 16. So this can never be 3 here. And 16, to get 16 with, you don't have 2, because 2 must be 5, 9, or 6, 8 to add up to 16 with the 2. So this has to be 1. This is then 2, which makes this not 2, so it's 1. No 1 here, no 1 here. And this must be 6 and 9 as a pair, which eliminates 6 and 9 in the rest of the column. So no 9 here. And the remaining digits are 2, 3, 7, 8 to add up to to add up to 20. No 3 here, though. So if we have 2 here, this would be 1. If it's 7 here, this would be 6 or 8. Cannot be 6 because of 6 in the column. If this is 8, this is 7 or 9. So where is 4 in column 5? It cannot be here or here because of 4 in the boxes. Can't be here because of 4 in the row. Can't be here because of what digits can remain here and be consecutive with that digit. So 4 has to be here, which means this cannot be 4. We have a 6-9 pair in column or in box 6, which eliminates 6 and 9 in the rest of the box. So there's no 6 or 9 there. It's 4. Okay. 7 eliminates 7 here. Okay. So what's done? Okay, so we finished X sum there, 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 X sum there. This is kind of dumb there. Unshaded regions, that X sum is done here. Unshaded regions, we're done there. We're done here. This is essentially done. This is essentially done. Kind of. And this is done. This is kind of done, and this is kind of done. Okay, so... let's just do remaining digits. Remaining digits of column 4, 3, 5, 6, 7, 9. Where is 9 in box or column box 8? Can't be here because of the way that this shaded exsum works. So 9 has to be one of these two, which eliminates 9 in the rest of the column. So no 9 there, no 9 there, no 9 there. Remaining digits in column 3 then. We have 1, 2, 3, 4, 5, 7, 8. No 4, 7 here because of 4, 7 in the box. No 3 here because of 3 in the row. No 3 here because of 3 in the box. No 1, 5 here because of 1, 5 in the row. No 4 here either. Where is 1 available in box 5? Cannot be here or here because 1's in the column. Can't be here because of 1 in the row. This is filled out, so 1 has to be here, which means it's consecutive with 2, which means this can't be 2. This is 8, which makes that 2 there. So no 2's here, no 1's here. 2 is eliminated there. 8 eliminates 8 here, so that's 3, which makes that not 3, so it's 7, which means this can't be 7, that's 9. That leaves that as 3 there. 9 eliminates 9 in the rest of the row, so this is 6, that's 9. 6 eliminates 6 in the rest of the row here, so this is 1, 7 as a pair. No 7 here, no 7 there. 3 eliminates 3 in the rest of this box here, so this is 5, that's 8. This cannot be 5 and 6 adding up to 11, so this must be 2 and 9 adding up to 11. Therefore, this cannot be 5. We couldn't have 5 there anyways. And it can't because if that were if it's 5, it has to be shaded, and the first 3 shaded digits would then add up to 12. So this must be unshaded here. This is shaded, and this is 5. This must be 8. Remaining 2, 9 eliminates 9 here, so it's 6 and 9. Remaining digit in row 5 is a 3. So no 3 here. No 3 or 5 here because of 3 or 5 in the row. No 5 here because of 5 in the row, so that's 8. No 8 here. No 5 here. It's 6, 9 as a pair. That eliminates 6, 9 in the rest of the row, so no 6, 9 there. It's 7. That leaves this digit as a 6. Remaining digits of row 6 are 1, 2, and 5. And this cannot be 6, 8, or 9, so it's 1. No 6, 9 here. No 1, 8 here. 1 eliminates 1 here, so that's 7, which makes this 1. 7 eliminates 7 here, so it's 9, which makes this 5, which makes that 4. No 4 or 5 there, it's 7. 5 eliminates 5 here, so it's 4 and 5. 9 eliminates 9 here, so it's 6 and 9. 6 eliminates 6 here, so it's 8. 8 eliminates 8 here, so it's 2, which makes that 6. 2 eliminates 2 here, so it's 5 and 2. 3 eliminates 3 here, so it's 7, which eliminates 7 there, so it's 5. 7 eliminates 7 here, so it's 9 and 7. 9 eliminates 9 in the rest of the row, so that's 6, which makes that 3. And this must be a 9. That was pretty cool, actually. I liked how these exsums and these shaded exsums and these sums, unshaded sums, worked out. Because it was it was more restrictive than I thought it was going to be, but it still had a lot of wiggle room there. So that was really cool, how that interacted. Very nice puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.